Page 215 from SciPAD. Question C continues on from question 2 above. It says calculate the kinetic energy of the two trolleys immediately after separation and use this to find the total energy provided. And so the type of energy they have when they're moving at 4 meters per second or 2 meters per second is going to be kinetic energy. And so essentially I'm going to be using our formula. Kinetic energy is a half mass times velocity squared. And if I do this for EK cut 1, which is going to be a half times 1 times minus 4, now in brackets squared, the 4 is just going to become 16, positive 16 because energy isn't really negative. So you've got 16 times 1 is 16 divided by 2 is going to be 8 joules. And then if I go EK2, it's going to be a half mv squared. And that second trolley had a mass of 2 kilograms and a velocity of 2 meters per second. So 4 times 2 is 8 divided by 2 is 4 joules. And so assume, okay, we're making an assumption, assume all the spring's energy is converted into kinetic. And so we're going to say E total. Change pen. E total is going to be 8 plus 4, which equals 12 joules of energy stored in that spring. Question 3, a car of 1800 kilograms has a velocity of that, is traveling east, collides with a stationary car. After the car, they stick together, and so that means they have the same velocity after. Calculate the initial momentum, and so P initial is going to be M1V1 plus M2V2, which is going to give us 1800 times 14, and now that's got to 3 significant figures potentially, plus the mass of the 4x4 to 500 times 0, because that's where I'm not clicking that yellow highlighter. Having some issues. Anyway, it does say it's stationary. And so we essentially have an 1800 kilogram car traveling at 14 meters per second. That's the only momentum kg ms minus 1. Find the mass when they are stuck together. Okay, so M total is going to be 1800 plus 2 500, which is 300, not joules, Mr. Harris. It's going to be kgs. Calculate the velocity after the collision. Okay, so we're making an assumption that momentum is conserved, and so we're saying that it has 25,200 kg ms minus 1 momentum, and that's going to be called mass times velocity, and the mass is going to be this total mass because the velocity is going to be the same, so it's going to be 4,300 v, and so what does the v equal? 25,200 divided by 4,300 gives us a speed of about 5.86 meters per second. Question 4, a 58 kilogram skydiver is falling towards the earth with a velocity of 40 meters per second. She grabs another skydiver with a mass of 70 kilograms who's traveling downwards at 35 meters per second. Calculate the total initial momentum of the system. This is a disastrous question. All right. So Pi is mass times velocity plus mass times velocity, which is 58 times the speed of 40 plus 70 kilograms times the velocity of 35. If I type that into my calculator, 58 times 40 plus 70 times 35, I get 4770 kg ms minus 1. The two skydivers are accelerating due to gravity after colliding, and they fall together at 40 meters per second. find the total momentum of the system. So I might still call that pi as mass times velocity. Now the mass is no longer 70, it's going to be 70 plus 58. And they're going to be times by 40. 58 times 40, 70 times 35. Yeah, good. I thought I made a mistake in the previous question. So we're going to go 70 plus 58 in brackets times 40. And that's going to give us an answer of 5120 kg ms minus 1. Compare the total initial and final momentums. Oh, okay, they're going to call that a final momentum, aren't they? That's okay then. I'll change that to a PF. Sorry, team. Explain whether this collision obeys the principle of conservation of momentum. Clearly it doesn't. I think that's the purpose. Okay, maybe it's not a disastrous question. Maybe they're trying to teach us something through that. That momentum is not conserved. Why is momentum not conserved? Because there is an external force. Where's the external force coming from? The external force comes from gravity. And so if we look at what that is, the total initial momentum is 4,770, while the final momentum is 5,120. This indicates an increase in total momentum, which shouldn't be possible. If anything, it always reduces because of friction, except if your skydiver is free-falling, having a collision in mid-air, which is due to gravity accelerating the skydivers towards the Earth. The conservation of momentum states that the initial momentum must equal the final unless acted upon by an external force. This principle is never broken, therefore the force of gravity is an external force, which is why we never do vertical motion momentum questions. Anyway, it's a good teaching point. That's the end of page 215.